Have you ever questioned the location of France's most significant nuclear fusion reactor? The process through which the sun and stars are propelled by atomic fusion has the potential to produce an endless supply of clean energy in the future. The motivations for France's technological leadership in nuclear fusion will be discussed in this video. ITER stands for International Thermonuclear Experimental Reactor. The name of France's nuclear fusion project, a collaborative initiative involving 35 nations, including the US, China, and Russia. It has an estimated $20 billion price tag. The reactor will begin operations in 2025 and is being constructed in the small French town of Cadarache. In the assembly hall of ITER, scientists and engineers are working to duplicate what occurs within the sun. This $22 billion research project, the largest nuclear fusion reactor in the world, has united a broad spectrum of nations in changing how the world generates power. Given the predicted doubling of the world's energy consumption by 2050 and the need to reduce our reliance on fossil fuels, ITER aims to develop a new carbon-free energy source that is urgently needed. The energy source behind the sun and the atomic bomb, nuclear fusion, may hold the key to finding endless power sources. ITER, however, aims to be the first reactor to create more energy through atomic fusion than it consumes. A reactor has never accomplished this accomplishment. General Secretary Gorbachev of the Soviet Union suggested a worldwide coalition to US President Ronald Reagan, sparking the start of the attempt to create fusion energy for benign reasons. The EU, Japan, Soviet Union, and the US decided to design ITER, a nuclear fusion plant, a year later. Thousands of engineers and scientists from the project's 35 member countries are engaged. Using nuclear fusion, the 23,000-ton reactor seeks to turn Earth into a miniature star that can provide energy for the entire planet. Fusion utilizes materials plentiful on Earth, such as hydrogen isotopes, as opposed to the fission process employed by traditional nuclear reactors. Nuclear fusion heat may be used to make steam, which powers generators and turbines to provide energy. To build a machine that can endure pressures twice as significant as those needed to launch a space shuttle and temperatures 10 times hotter than the sun's core is a difficult task. A machine that can resist extremely high temperatures and pressures are still necessary to achieve effective, scalable nuclear fusion on Earth. The world's energy supply might undergo a revolution if ITER effectively produces net energy, which is created but not consumed. Fusion power promises to become an endless supply of carbon-free energy, eliminating reliance on fossil fuels. Even though several organizations are working to harness nuclear fusion, ITER is the biggest and most ambitious. Plasma, a state of matter that resembles gas, is produced by injecting hydrogen atoms into a vacuum vessel and then turning on a massive superconducting magnet that removes the electrons from the particles. After the plasma is heated to extremely high temperatures, the atoms combine to create a nuclear process that releases significant energy. Compared to atomic fission, this method generates 4 times as much energy as burning coal, oil, or gas. With 1 million components and 10 million pieces produced by the ITER member nations, the tokamak is the most potent fusion device in the world. Colette Ricketts is responsible for ensuring that the parts required for ITER are delivered on schedule, in the right color, form, and quantity. She also serves as the ITER organization's deputy head of the Project Control Office. The 104 kilometers of road, known as the ITER itinerary, have been particularly adapted to handle the numerous heavy components needed. In the gigantic assembly hall, enormous cranes assemble parts before being hauled into the reactor. Despite decades in the making, ITER's construction is constantly touched by world events like pandemics, Brexit, and political elections. To maintain the project on schedule, adaptation and rescheduling are necessary. Collaboration is crucial given the 35 participating nations, and Think Project administered contracts for close to 400 customers spread over 30 companies. ITER is a significant investment in clean energy and a crucial step in our move away from fossil fuels. To create more energy than it is utilized, or net energy, the vast fusion energy project is scheduled to start the first plasma generation in 2025. Although it will take many decades, additional reactors may try to implement the energy produced into the current power networks. fusion power is being raised to become economically feasible and compete with fossil fuels through various alliances and private businesses. The world's reliance on fossil fuels would decline if carbon-free energy production could be scaled up for commercial use. The construction sector plays an essential part in this project. Finally, France's leadership in nuclear fusion technology may be linked to various elements, such as its proficiency in nuclear engineering and technology, its dedication to reducing its dependency on fossil fuels, and its solid collaborations with other nations. Nuclear fusion may be crucial as the world transitions to a more sustainable and clean energy future, and France is at the forefront of this significant scientific advancement. Why do we have more than ever to invest in renewable energy? Leave us your comment down below.